Today we're going to be talking about dynamics graphing. In dynamic graphing, there's a simple formula that we'll be going over and having more information about, which is F equals ma. Newton studied how objects move, and he noticed some patterns. He observed that the object acceleration of an object depends on the mass of the object and the size of the force applied to it. States that the acceleration of an object increase with increased force and decrease increased mass. The law also states that the direction in which an object accelerates is the same as the direction of the force. Mass is also a variable in Newton's second law. If the force acts on two objects, the objects with less mass will have a greater acceleration. For instance, if you push a soccer ball and a bowling ball with equal force, the soccer ball will have a greater acceleration. If objects lose mass, they can gain acceleration. If the force remains the same when a rocket is first launched, most of its mass is the fuel it carries. As a rocket burns fuel, it loses mass. As the mass continually decreases, the acceleration continually increases. Usually we think of force as either speeding up or slowing down. The motion of an object, but force can also make an object change direction. If an object changes direction, it is accelerating. Newton's second law says that if you apply a force on an object, the direction in which the object accelerates is the same as the direction of the force. You can change the direction of an object without changing its speed. For example, a good soccer player can control the motion of a soccer ball by applying a force that changes the ball's direction but not its speed. The product of a mass times gravitational acceleration mg is known as weight, which is just another kind of force. Without gravity, a massive body has no weight, and without a massive body, gravity cannot produce a force. In order to overcome gravity and lift a massive body, you must produce an upward force ma that is greater than the downward gravitational force mg. If an object is moving with a constant acceleration, what will be the net force acting on the object? Constant, because the Newton's second law, A equals force divided by mass. Since the mass is not changing, it is in this case relativity corrections or to be ignored, and the acceleration is constant. Therefore, to make F divided by m ratio constant, the force F must be constant.
Okay, by the Newton's second law, if you apply a small force, then the acceleration is also slow. Like the cart is moving at a slow pace because he's pushing, his force is not that big. Okay. This demonstration, if you apply a lot of force, then the acceleration is increasing. As force increases, acceleration also increases in this demonstration. So in this demonstration, we increase the mass, therefore it's a decrease in acceleration.
To do an example of dynamic graphing, we're going to use a simple formula, F equals ma, for this type of problem. So in the problem it states, what force is needed to accelerate a 10 kilogram shopping cart 3 meters per second squared? So it gives us the mass, which is 10 kilograms, and acceleration, which is 3 meters per second squared. So what do? Just plug it in. F equals ma, replace that 10 with that's the mass, with 3, and force equals 30 newtons. Don't forget your units. If a team pulls with a combined force of 9,000 newtons on an airplane with a mass of 30,000 kilograms, what is the acceleration of the airplane? So going back to the formula, F equals ma, we're gonna derive it so we can find the acceleration. So to find it, we're just gonna divide m on both sides and then end up with A equals F divided by m, and just plug in what we already know. So we know 9,000 newtons, that's the force, divided by 30,000 kilograms, which will equal 0.3 meters per second squared. Don't forget your units because this is acceleration, and that will be your final answer.